Now students, let us start the topic permutations. I have already told you what is permutation, so let us see again. What is permutation? The different arrangements that can be made out of a given set of things. The different arrangements that can be made out of a given set of things by taking some or all of them at a time are called permutations. So the number of permutations of n things taken are at a time is denoted by NPR. The number of permutations of n things taken are at a time is denoted by NPR. And students, NPR is equal to, we have discussed so many questions on NPR, and we know NPR equal to n factorial upon n minus r factorial. And the number of permutations of n different objects taken all at a time is NPN, and this is equal to n factorial. So here we are taking r at a time, and here we are taking all at a time. So when number of permutations of n things taken are at a time, then it is equal to NPR, and number of permutations of n different things taken all at a time is NPN, and this is equal to n factorial, right? Now let us take an example. Suppose we have three letters ABC, and we want to arrange them two at a time. So arranging three letters two at a time by taking two at a time. So this is equal to 3p2. Now students, 3p2 means 3 factorial upon 3 minus 2 factorial, and this is equal to 3 factorial upon 1 factorial, and this is equal to 6. So it means there are 6 arrangements. Now I tell you, the 6 arrangements are AB and BA, then BC and CB, then AC and CA. So these are the students 6 arrangements. So when we want to arrange 3 letters by taking 2 at a time, then number of possible arrangements will be 6, and these 6 possible arrangements will be AB, BA, BC, CB, AC and CA. So these are the 6 possible arrangements. And if we write arranging 3 letters by taking 3 at a time, so students, this is equal to 3p3, and this is equal to 3 factorial, and this is equal to 3 into 2 into 1. This is also 6. When we take 3 letters, when we want to arrange 3 letters by taking 3 at a time, then number of arrangements or number of permutations equal to 6. And students, these 6 arrangements will be ABC, ACB, BAC, then BCA, then CAB, and then CBA. So these are the 6 possible arrangements. So if we want to find out arranging 3 letters by taking 3 at a time, then there will be 6 arrangements. So to find it, we use 3p3. So 3p3 equal to 6. So the answer will be 6, and these are the 6 possible arrangements. Now students, we'll start the exercise now. Now students, let us start with the very first question of exercise 6.4, which is based on permutations. Now first question is, in how many ways can 6 children stand in a queue? In how many ways can 6 children stand in a queue? So let us see in how many ways 6 children can stand in a queue. So students, here we write number of permutations, or we can write number of ways. Number of permutations of all 6 children. Number of permutations of all 6 children taking 6 at a time is equal to 6p6. Number of permutations of all 6 children taking 6 at a time equals to 6p6, and this is equal to 6 factorial, and 6 factorial is equal to 720. Right students? So it means there are 720 ways in which 6 children can stand in a queue. Now second question, in how many ways can 5 women can draw water from 5 taps if no tap remains unused? So students, there are 5 women and 5 taps. So number of ways, or we can write number of permutations, number of ways in which 5 women can draw water from 5 taps taken all at a time. Taken all at a time is equal to 5p5. This is equal to 5 factorial, and this is equal to 5 into 4 into 3 into 2 into 1. So this is equal to 120. So number of ways in which 5 men can draw water from 5 taps taken all at a time equals to 5 factorial equal to 120. So I hope students this is clear to you. Then in how many ways? 4 different books. So here we have 4 different books. One is of chemistry, other is from physics, then biology and maths. We have 4 books. One book is of chemistry, one is of physics, one is of bio, and one of maths. So in how many ways can 4 different books be arranged in a shelf? So students, there are 4 different books. There are 4 different books. One each in chemistry, physics, biology and maths, right? The number of ways these books can be arranged among themselves in a shelf is, so 4p4, this is equal to 4 factorial, and 4 factorial is 24. So students, it means there are 24 ways in which 4 different books can be arranged in a shelf. Now, number fourth question, students. The fourth question is, there are 3 different rings to be worn in 4 fingers. 3 different rings. 3 different rings uh, to be worn in 4 fingers. To be worn in 4 fingers. So with at most 1 in each finger, in how many ways this can be done? So students, here we write 3 different rings. 3 different rings can be worn in 4 fingers with at most 1. With at most 1 in each finger in 4p3 ways. 4p3 ways. 3 different rings can be worn in 4 fingers with at most 1 in each finger in 4p3 ways. And we know what is 4p3. This is 4 factorial upon 4 minus 3 factorial. This is 4 factorial upon 1 factorial. And this is equal to 4 into 3 into 2 into 1. So there are 24 ways in which 3 different rings can be worn in 4 fingers. Now there are in all 3 plus 2 plus 4 equal to 9 books, and these 9 books can be arranged among themselves in 9p9 ways. It is equal to 9 factorial. And how to solve 9 factorial? 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So on solving with calculator, we get 362880. So these are the possible number of ways when, if the books are of same subject are different, then number of possible arrangements will be 362880. Now the second part is the number of possible arrangements if the books on a particular subject are to be together. Now it means 3 economic books, E2, E1, E2, E3, these are economics books, 2 history books, H1 and H2, and 4 English books, suppose L1, L2, L3 and L4. Now according to this part, the number of possible arrangements if the books on a particular subjects are to be together. It means English books, history books and economics books, they should remain together. Now students, if we see, there are three sets. One, this is first set of economics books, second set of history books, and this is the set of English books, third set. So there are 3 sets of books. So I am writing the language. There are 3 sets, 3 different sets. We can write like this: 3 different sets. There are three different set of books. There are three different sets of books. The first set has three different books on economics. Second set has two different books. Two different books on history, right? And third set has four different books on English. Books on English, right? So these three sets can be arranged in three p3 ways. This is equal to 3 factorial, and this is equal to 3 factorial means 3 into 2 equal to 6. So these three books can be arranged, these three sets can be arranged in 3 factorial ways, means 6 ways. Now, three books on economics. Three books on economics can be arranged among themselves in 3p3 ways. This is equal to 3 factorial equal to 6 ways. Then similarly, two books on history can be arranged among themselves in 2p2 ways, means 2 ways. And four books on English can be arranged in 4p4 ways, means 4 factorial, and 4 factorial is 24 ways, right? So therefore, total number of possible arrangements is equal to it will be 6 into 6 into 2 into 24. So 6 from here, 6 and then 2 and then 24. So total number of possible arrangements equal to 6 into 6 into 2 into 24, and this is equal to 1728. So this is the working of this question, students. So I hope this is clear to you. Now number 6 question, students. Number 6, the statement is, how many 6-digit telephone numbers can be constructed with the digits 0, 1, 2, 3, 4, 5, 6, 7 and 8, if 8 and 9 also, if each number starts with 35 and no digit appears more than once, and we want to make a 6-digit number. So students, here we want to make a 6-digit number 1, 2, 3, 4, 5, 6, and these two places number will start by 35. So it means these two places are fixed, right? So we write the first two places of 6-digit telephone number, 6-digit telephone number are fixed and are fixed for 3 and 5. ये जो हमारे फर्स्ट टू प्लेसेस हैं ये हमने 3 और 5 से ही फिल करने हैं by 3 and 5. Now no digit should appear more than once. Now total letters we have 10. Total digits we have 10, and out of 10 we have fixed 2 digits, 3 and 5. So we are left with 8 digits. So we are left with 8 digits. And how many places? 1, 2, 3, 4, and 4 places. Now see again, we have 10 digits, and out of 10, 2 digits are filled up over here. These 2 digits are fixed, 3 and 5. The telephone number must start from 3 and 5. So out of 10, 2 digits, 3 and 5 are filled up over here. Now we are left with 8 digits and 4 places. So we are left with 8 digits and 4 places, and which can be done in 8p4 ways, right? And 8p4 equal to 8 factorial upon 8 minus 4 factorial. So this is equal to 8 factorial upon 4 factorial. So on solving it, we get 1680. So therefore total number of telephone numbers that can be constructed are 1680. Now sum number 7. In how many ways can 6 boys and 5 girls be arranged for a group photograph if the girls are to sit on chairs in a row and the boys are to stand in a row behind them? So simple question, students. So there are 5 girls. So 5 girls can sit. 5 girls can sit on chairs in a row in 5p5 ways, and 6 boys can stand in a row in 6p6 ways. We have 5 girls, so 5 girls can sit on chair in 5p5 ways, and 6 boys can stand in a row in 6p6 ways. So therefore total number of arrangements. Now 5p5 is equal to 5 factorial, and 5 factorial equals to 120, and 6p6 equals to 6 factorial, and 6 factorial is equal to 720. So total number of arrangements 120 into 720. So this is equal to 86400. So this is the answer, students. I hope this is clear to you.